everyone, this is Vidya. So today's topic in DS we are going to explain about the stack applications. So let us see what we have told in the last video and what I'm going to continue today. So as per syllabus we have completed the introduction of DS and abstract data types and what is stack ADT and stack operations and stack implementation using arrays. So today we are going to see into the stack applications. So what are the stack applications? Let us see. After that we have some expressions and evaluation we have. Let us see what are those. Okay. So coming to the today's topic, the first topic we are going to see the stack application. Next, what is an expression? Types of expressions. Next, precedence, associativity and algorithm for infix to postfix. So stack applications. So stack applications are mainly used to convert an infix expression to postfix expression and in the evaluating the postfix expressions. Next, to implement the recursive procedures and even for the compiler design also we are going to use this stack. So let us see first of all what is an expression. So then we can see what is this infix, postfix and prefix. So coming to the expressions. So here the expression is a combination of operands and operators. So the expression consists of both operands and operators. So let us see what are these operands and what are these operators. So we have three types of expressions here. One is infix expression, next one prefix expression and next one is postfix expression. So coming to the infix expression, so in the infix expression, the operator is said to be in middle of the operands. Here in this particular expression, where plus is an operator and A and B are the operands. So the operator is said to be in the middle of the operands. So next coming to the prefix. So prefix means pre means before. So the operator is said to be before the operands. So here the place is being placed before the operands and where A and B are the operands. So this is called prefix expressions. Prefix expression is also called as Polish notation. Next, postfix expression. Post means after. So the operator is placed after the operands. So AB place where A and B are the operands and place is the operator. So postfix expression is also called as reverse Polish notation. Okay, so these are the expressions and these are the types of expressions what we have. So before going to the problem, even we have two more important definitions, that is precedence and next is associativity. So we'll see what is this precedence and associativity. So precedence. So precedence means what is that? So if the operator is having the highest priority, how we have to evaluate? So we have number of operators, but we can't evaluate all the operators at the time. So according to the priority, we are going to evaluate them. So that tells about the precedence. Next, coming to the associativity rule. So let us see what is this. If we have two or more operators of the same precedence, if my same operators I'm having in that particular expression, if both have the same precedence, then I have to go for this associativity rule. So what is this associativity rule? We have two here. So how we have to evaluate is that one is left to right and other one is right to left. So we have particular table. So which associativity rule we have to follow, whether left to right or right to left, depending upon the precedence. So this is a small example table what I have given. So here both parentheses means we have square brackets, round brackets, flower brackets. So all these parentheses have the highest more priority. So when this parenthesis is occurred, so we have to go for left to right associativity rule. Next. The next precedence means the next priority is given for the power. So when power is coming, we follow right to left associativity rule. After that, we have given the priority for the division and for multiplication, star and division. So these are the precedence we are going to follow and left to right associativity we are going to follow. The next priority is given for the plus and minus, addition and subtraction. So for this, we are going to go for the left and right associativity rule. So let us see the few examples how we are going to evaluate them. So example I have here 1 plus 2 star 5 plus 30 by 5. So here what we have to go first, we have here multiple operators. So depending on these operators, we'll follow the precedence rule and we are going to evaluate. So as we have seen in the previous table, the star and division are having the same priority. Okay, so they are the highermost priority compared to plus, so we will go for star and division. But now both are having same priority, so now we have to go from associative rule. So what my associative rule is telling, when I'm having this multiplication or division symbol, I have to evaluate from left to right. So I'm going to evaluate from left to right. So first 2 into 5. So 1 plus 10 plus 30 by 5. The next priority anyway, division. So 30 by 5. So 30 by 5 I am having 6. So after that I'll go for the addition. So I am having same, again addition is also having left to right associative rule only. So 1 plus 10 11, next 11 plus 6 17. So this is how we have evaluated. So one more example, we have power cap. So 2 to the power of 2 power of 3, we have this an example. So when we are coming to the example, so both operators are same, both power cap, but here the same precedence. I don't know whether I have to evaluate 2 to the power of 2 or 2 to the power of 3. So what does my table is telling, when I'm having this exponential, I have to go to left to right rule. So when I'm coming to the right to left, so that we are going to take this particular value, 2 to the power of 3, that is 8, 2 to the power of 8 is 256. So this is how we are evaluating by taking the precedence and associative rules. So few examples, and here we have one more note, that is, if parenthesis is given, no need to check with the precedence or associative, directly we can go. We are having the precedence, sorry, we are having the brackets. So the next we are coming to the algorithm for infix to postfix. So let us see, we have few steps. Anyway, in example, again I'm going to repeat where we are using the steps, but let me explain. So initially the stack is said to be empty, the step 1. So next step 2, if the stack is empty, it contains left parenthesis on the top of the stack. So push the incoming operator into the stack. Okay, next, if the incoming symbol is open parenthesis, push into the stack. In case if the parenthesis is closed, so we have to pop out from the stack. If the incoming symbol is having higher precedence on the top of the stack, so it is telling to push into the stack. In case the lower precedence operator is coming, then we have to pop out from the stack. If the incoming operator has equal precedence on the top of the stack, then again we have to use the associative rule. So this is how we are going to do all the operations in the stack by using this infix to postfix. By using stack, we'll do this. So at last we are going to pop out all the elements from the stack. So this is the algorithm. We'll go with the example. So we have taken this example, just one expression, 2 minus 3 star plus 5 star 8 minus 4 by 2. So initially the stack is said to be empty as per the algorithm, and in the postfix expression we are going to have null. So we'll see how the operators and operands are going to move. So if I am having an operator, that will be pushed into the stack. If I am getting operand, that will be printed in the postfix. So initially I have an operand. So here in the second step, the stack is also said to be empty. So the 7 has been printed in the postfix expression. So now the incoming symbol is operator, so that has been pushed into the stack and 7 will be printed as it is. So the incoming symbol, again we have here open parenthesis, so that will be pushed onto the stack. So 7 will be printed here. So the incoming symbol is an operand, so that will be not pushed into the stack, it will be printed in the postfix expression. We have 7 2. The next incoming symbol is star, So the star will be pushed into the stack, and in postfix we have 7 2. The incoming symbol is 3. So it is an operand that will be not pushed into the stack. It will be printed in the postfix. So the incoming symbol, now we have an operator that will be pushed into the stack, that is place. So here again the operator and other operator is coming. Here we have given in the algorithm, just look here. So if the incoming symbol is having lower precedence, which is on the top of the stack, then the element is said to be popped out. So where the plus is having a lower priority than the star, so plus is being pushed into the stack and star is said to be popped out into the stack. So we are going to get 7 2 3 star. So star symbol has been popped out from the stack. So plus is there in the top of the stack. So next incoming symbol is an operand. So we are going to have 7 2 3 star 5. Next we have the close parenthesis. Already as per the algorithm we have told if the incoming symbol is the closed parenthesis in the step 4. So the top of the stack is going to be popped out. So what is there? The plus symbol is there. So 7 2 3 star 5. So the plus symbol has been popped out. The next incoming symbol is minus and star. So when the highest priority is there, as per the algorithm in the step 5, if the highest precedence we are going to have, it is going to pushed into the stack. So we are going to have star here. So 7 2 3 star 5 plus. So as it is going to be. So in stack I have 8 minus 4 by 2. And in stack I have minus and star symbol. So in postfix I have 7 2 3 star 5 plus. Okay, so this is 5 plus we have. So we'll see again what. So the incoming symbol is the open parenthesis. So that will be entered into the stack. And in postfix we are going to have 7 2 3 star 5 plus. Okay. So next incoming is the operand. So the operand will be printed in the postfix 7 2 3 star 5 plus 8. So we have it. So the next incoming symbol is minus. Minus will be inserted into the stack. So next incoming symbol is 4. So it is an operand. So that will be just printed in the postfix. 7 2 3 star 5 plus 8 4. Next the incoming symbol is division symbol. So here again as per our algorithm, division symbol is having the highest priority when compared to the minus. So highest priority means we are going to insert it. So just we are going to insert it. 7 2 3 star 5 plus 8 4. Next is a 2. So we are going to have 7 2 3 star 5 plus 8 4 2. So the next coming is an operator as it is a closed parenthesis, and this is said to be empty. The complete infix expression we have completed. So as we are getting this closed parenthesis, we know that if any operators are there inside open and closed parenthesis as per algorithm, they should be popped out. So as per top we are going to get. So when we are getting this, topmost element is 7 2 3 star 5 plus 8 4 2 by. So it follows LIFO rule, last in first out. So we have division, next minus we have. So after that each and every element will be popped out. Again the stack is also said to be empty for the next step. So we are going to have 7 2 3 star 5 plus 8, 4, 2 division star division. Sorry, minus 7, 2, 3 star 5 plus 8, 4 by 2. So this is the complete expression what we have taken and what we have evaluated. So this is the infix expression what we have taken, and this is the postfix expression what we have done after the evaluation from infix to postfix. So let us see what are the topics we have discussed today. So we have seen stack applications. Next, we have seen what is an expression. Next, types of expressions. Next, we have seen how to convert infix to postfix. So in the next video, we are going to see the postfix evaluation. How to evaluate the postfix evaluations. Here we are going to have an algorithm. Again, we are going to have the problem. We are going to discuss in our next session. Okay. If you have any doubts, you can ping me. Thank you.